Hello, Professor. This is Bhavna Bulabali, and my partner is Ruchi Reddy Kotla. This video is for the explanation of ICP7 of big data. Firstly, for creation of autoencoder, we have imported the necessary libraries, um, and here we need MINS dataset. So we are importing MINS dataset and models and batch normalizations, which we use for encoder and decoder respectively, and we import the necessary layers, convolution, two-dimensional layers and flattened layers, dense layers, and to reshape values. And these all necessary layers we have imported. And firstly, as we require the MINS dataset of it means dataset which contains 28 and 28 pixel images. We have written the date, imported it here by sending the input train and test data, and here we have found the sizes of our input train and test data here. It shows like it is 60,000, and we want to reduce it to the 10,000 images and 1,000 images respectively, and we have written the code for that here. And we are printing the first 10 images in the training set, and and the output is shown here. To do the encoding process, we are printing the first 10 images, and we are printing the shape of those train and test data here. And here we are configuring the model, and for that we are passing these parameters of batch sizes of 128, epochs we required, verbosity is set to 1 so that it is set to true, so that the content is output is shown on screen. And we are taking the latent dimension of 2, and we are taking the number of channels is equals to the number of image channels, and for RGB it is 1, so we are initializing it as 1 here. And here we are we want the data in the form of 28 28 1, and we with the x, which is the number of samples, and we are reshaping the data here. And we are using parse numbers as it will fasten the process, and we are normalizing it because as the data is in big numbers, we want to normalize it. And to normalize, we are parsing the input data. And to create encoder, first we need to define the encode input. We have to define the encoder. For defining the encoder, we want to initialize the input data what we have taken, and we are using conventional two-dimensional convolutional two-dimensional layers. And for that we are passing filters as 8 and kernel size as 3, and we are taking stride size as 2. And we are using a layer activation ReLU. And to pass the data of convolution layer, this first layer to second layer, we are using batch normalization, which we have initialized here. So the output of this layer is sent to the output of sent as input to the second layer using batch normalization. And here we additionally added a convolution layer of filter size of filters 32 size and kernel size 3 and stride size of 1. And we have added the batch normalization layer here. To flatten the data into one dimensional, we are using flatten, and we are using a dense layer of 20. And we are doing the batch normalization again, and we are printing the um, mean values of the output here and the sigma of the output here by passing it to the dense function. And here we are taking the convolution shape here, and we are reparameter as the expected loss is minimized here. We are reparameterizing it by using this function. We are defining the sample here. As we need good differential exceptional loss, we are defining here, and as it is not possible by the above, as we are losing it by the above actions, we are defining it here using a different function. And here we are defining it by using lambda. This is how we initialize the encoder by passing the input and mean value sigma and z, and we have summarized it here, and the output is shown here. And now we are defining the decoder, which is exactly here. To define the decoder, we define the input first, and then we initialize the dense layer, which is a average of three, which is multiplication of three convolution shapes, and we define it here. And we are batch normalizing it here again, and we reshape it here by passing the data of dense layer into this reshape layer. And here, as an encoder, the filters are the last defined filter is 30 of size 32. We have to define it here first. So we are defining the filter size of 32 and the batch normalization then, and we are defining our respective filters of in the descending order. And we have done the defining of decoder here, and we are initializing it here, and this is a summary of the decoder. And this is how we initialize our variable autoencoder. First, we define the outputs by putting the encoder inside the decoder, and we are summarizing it here as shown. And this is how we here we are doing the compilation and training of the variable autoencoder, and we are using optimizer as Adam and a binary cross entropy loss. And here we are initialization, we are defining it to overcome the variable autoencoder fit error. And we are running the epochs here, and for results for showing the output, we are defining the latent space and weight decoded here, and we are defining it here. And we are initializing it here, and by passing encoder and decoded data. And this is the output we got for latent space and decoder respectively. And when compared to the previous output, the output is shown more clear and more precisely um, by adding extra layers for decoder and encoder and decoder respectively. Thank you.